Uh, Hello, good morning. In this particular sessions of the second year BSc, uh, we are going to discuss the electric and magnetic field disturbance propagation or the electromagnetic wave. Okay, this is what we are discussing. So we know the four Maxwell's equations. Uh, First one was actually the del dot E is equal to rho by epsilon, and the second del dot B equal to 0. Third, del cross E is equal to minus dou B by dou T, and the fourth one, del cross B is equal to mu epsilon. So sigma E plus and dou E by dou T. So this is the fourth equation. And using those fourth equations, Maxwell's were able to set up an electromagnetic wave equations. It's a simple mathematical adjustment. For the simplest of the case, we are taking here the electromagnetic wave in the free space. Okay, electromagnetic wave in free space. Free spaces means there is no charges, isolate charges. So therefore, this particular part, del dot E is equal to rho by epsilon, that becomes 0. Okay, so if there is no charges, if there is no charges, then this del dot E becomes 0. Similarly, del dot B becomes, see, this is an equation reduced free space or vacuum where there is no free charges. That's why this. And then this is del cross E, the third equation, and this is the fourth equation. Again, there is no free charges. Therefore, the first part, the current density, the conduction current density part is not there. Okay, this is the displacement current density part. Now what I am doing is this equation 3 I am taking, and to this equation 3 I am going to apply curl. Okay, taking the curl on the equation 3. Here also you take the curl. Okay, and here also you take the curl. So that is del cross E is equal to this. Now this you can take it inside. Dou by dou T is the function. So this you can take it inside. Now I am taking the curl on both the equations. So you can take this curl inside, that is mathematically allowed. Okay. So now the equation becomes the like this. Del cross E. This particular part, del cross E is nothing but del cross E is nothing but gradient of divergence of E minus del square E. This is a Laplacian operator. So it becomes like this. And in this, gradients of divergence of a vector is always going to be 0. Gradient of divergence of vector is going to be 0. Therefore, this becomes this, in that the first term is going to be 0. So what is left here? Minus del square E. Minus del square E is left on this particular side. Minus del square E, that is equal to minus del cross dou B by dou T. So if the minus is there, it was print mistaken here, minus del square E. Okay. Now you take it this one inside. When you are taking this inside, del cross B, it becomes del cross B. In the place of del cross B, you write this mu naught epsilon dou E by dou T. So when you are writing mu naught epsilon naught dou E by dou T, it becomes dou square E by dou T square. Okay. So del square E is equal to mu naught epsilon dou square E by dou T square. So carefully observe. I took the equation 3 and a curl is applied to this on both sides. Del cross E equal to this. Now this del cross E is nothing but gradient of divergence of vector minus del square that vector. But this value is going to be 0. Therefore, this equation reduces to minus, remember it was not printed here, minus del square E, that is equal to minus del dou B by dou T. So take this one inside, mathematically it is allowed. So in the place of del cross B, you substitute the fourth equation, mu naught epsilon naught dou E by dou T. When you substituted that, it becomes mu naught epsilon dou square E by dou square. So this side minus is there, this side also minus, that cancels. This is an equation. Del square E is equal to mu naught epsilon dou square E by dou t square. So this is one of the equation to be removed. Similarly, you do it. Now you start from this. Take the curl on this particular equations. To the equation 4th, you apply the curl. So when you are applying the curl to the equation 4, it goes like this. Look at del cross B. Okay, same way. The first term is 0 minus del square B, that is equal to del this mu naught epsilon dou E by dou T. This you can take it inside. So when you are taking it, it becomes mu naught epsilon dou by dou T del cross E. Now from the equation 3 you substitute this. Del cross E is nothing but minus dou B by dou T. Therefore here the minus comes. Here already a minus is there. So this minus and this minus cancels. So you're going to get this del square B is equal to mu naught epsilon dou square B by dou T square. And in the previous, del square E is equal to mu naught epsilon dou square E by dou T square. Now consider the equation and consider this equation. So these two equation I wrote here, del square E mu naught epsilon dou square E by, look at, they are identical. And this you study, del square x is equal to 1 by v square dou square x by dou t square. What is this? This is going to be the differential form of the progressive wave equation. This is the differential form of the progressive wave equation. Whenever wave is propagating, the disturbance is propagating, this is the differential form. And if you compare this differential form of the progressive wave equation to the equation of the electric field and the magnetic field, okay, so this electric field and the magnetic field, comparing with this, they are identical. Del square x, here del square E, and dou square x by dou t square, here it is dou square E by dou t square, identical. So from this we can conclude the first step, and this electric field disturbance and the magnetic field disturbance is similar to progressive wave equations. Therefore, it is also going to be the progressive wave equation. This is the progressive wave equation for the electric field, and this is going to be the progressive wave equation for the magnetic field. Okay, so electric field disturbance propagates, the magnetic field disturbance also propagate, because these two equations are similar to our differential form of the progressive wave equation. So from this we can conclude the electric and magnetic field disturbances are propagating through the medium. Now if you are saying if they are propagating through the medium, we should say with what velocity. That is why I am just comparing these equations. So when I am comparing the differential form of the progressive wave equation with the electric field disturbance, magnetic field disturbance equations, that is electric field wave equation, the magnetic field wave equation, I found in general, okay, 1 by v square is nothing but the mu epsilon. This is in general. I just compared, I should write mu naught epsilon naught. So mu naught epsilon become the special case, air or vacuum, or in general 1 by v square equal to mu epsilon. Okay, or mu is equal to 1 by square root of mu epsilon. Now you do this. Instead of this one, you take the example what we have taken here for air or vacuum. So this becomes mu naught epsilon naught. So mu naught is nothing but 4 pi into 10 to the power minus 7. Epsilon naught is nothing but 8.852 10 to the power 9 Newton per SI units. So this is called the permittivity of the air or vacuum. Is the permeability 8.852. Okay. So into 10 to the power 9. So when you are going to substitute this, the value is found to be 2.999 into 10 to the power 8 meter per seconds. So now this is a curiosity. What is this electric field disturbance? What is this magnetic field disturbance? If you compare this electric field and magnetic field disturbance with this one, we can understand since they are similar, so this electric and magnetic field disturbance also propagating. With what velocity? We found 3 into 10 to the power 8. We know this is the value of velocity of light in air or vacuum, and with the same velocity our electric field disturbance or magnetic field disturbance is propagating. Therefore it gives me the insight, or it gives me the hint. Why can't I assume the light as an electromagnetic wave? Because the velocity with which the light wave propagating, 3 into 10 to the power 8. Velocity with which the electric and magnetic field disturbance propagating is also going to be same. Light doesn't require medium, this also doesn't require medium. And the velocity is very high, here also velocity. So all these makes us to assume most probably the light is going to be electromagnetic in nature. So that's what the conclusion we are getting after the so-called fourth Maxwell equations. To confirm this is the velocity of electromagnetic wave is this much. This is exactly the velocity of the light wave. The properties associated with the electromagnetic waves are exactly same as that of the light wave. That's why I'm considering the light is treated as an electromagnetic waves. Okay. So now some of the interesting ideas. When this electromagnetic wave travels through the transparent medium, so velocity of electromagnetic wave is this. So this mu, permittivity of medium, when you relate this permittivity of medium to the air or vacuum, our mu become mu r and mu naught. Epsilon becomes epsilon r, epsilon naught. So this I'm writing it here after splitting it, mu naught epsilon together, mu r epsilon r together. So this part is nothing but the speed c. So v is equal to c divided by this. Just focus here, velocity of wave, electromagnetic wave through the medium is equal to c divided by this. Suppose this denominator value is 1, then we can conclude that electromagnetic wave travels through the speed of the light, that is 3 into 10 to the power 8. But look at, if you are considering any medium other than air or vacuum, this mu r value is more than 1, epsilon r value is more than 1. Again remember, medium other than air or vacuum, mu r greater than 1, epsilon r is greater than 1. Therefore, this denominator term is not 1 but more than 1. So, c divided by more than 1, say 2, then what happens? V value becomes c by 2, or the V value become less than the c. So, this is what we are observing in the case of a light. Whenever the light is traveling through certain medium, the velocity, rarer to denser idea, the velocity decreases. Exactly the same thing we are observing in the case of a electromagnetic wave also. When this electromagnetic wave travels through any other medium, the velocity of the electromagnetic wave found to be decreasing or less than that. Okay. So this term c is v is equal to c by this, slightly modified. C by V I did it. So that is nothing but root mu r and epsilon r. So this is the ratio of speed of light in air or vacuum to the ratio of the speed of the light in a medium. That's nothing but the refractive index. Okay. So from this particular term, I can get the idea of a refractive index. That's nothing but mu r into epsilon r, or n is equal to square root of mu r epsilon r. You square it, n square is equal to mu r epsilon r. For non-magnetic and transparent medium, this mu r value is going to be 1. Then n square equal to epsilon r. This is considered to be the Maxwell equations. But what important for us is, say we came to know electric field produces the magnetic field, and similarly the magnetic field produces the electric field. This idea will. So that this electric field disturbance and the magnetic field disturbance are mutual generation. One induces the another one. So these disturbances propagates through the medium exactly same as the progressive wave. Therefore, we can conclude the electric field magnetic field disturbance travels. Now comes the question, with what speed? 3 into 10 to the power 8. So meter per second. This is equivalent to the speed of the light in air or vacuum. So that gives us the hint, why can't we conclude the light is going to be electromagnetic wave. And I have shown some of the properties, especially doesn't require medium, or when electromagnetic wave traveling from rarer to denser medium, the speed is going to be decreased, or the idea of a refractive index. So these all indicates that the properties associated with the electromagnetic wave and the light are going to be identical. So we can conclude the light is electromagnetic in nature. Okay. So with this, I'm going to stop today's sessions. In the next sessions, we are going to prove the so-called the light. It is electromagnetic in nature, plus it is going to be the transverse in nature. So that's what we are going to discuss in the next class. Okay. Thank you.